In this video, we are going to review what we learned in our Thelma and Louise lesson. So let's first review what that lesson was about. In that lesson, we learned how to make calculations of the horizontal projectiles off a cliff. Through demonstrations and discussions, we concluded, as a class, that our x and y vectors must be calculated separately and individually since they are independent of each other and run perpendicular to each other. With that, we realized that the first step we must take is to break our vectors into x and y. So let's take a look at this example here. A car drives off a 500-meter cliff, driving 40 meters per second. What is the horizontal distance of the car before it hits the ground? So as we could tell, once again, this is kind of like our Thelma and Louise questions. Basically, we have a vehicle or a projectile going horizontally off a cliff. So let's kind of draw this out to see what we're dealing with. So right here I have a cliff that is 500 meters. Okay? And we are going horizontally at 40 meters per second. And it's going to keep on going till they hit the ground. So once again, we must first break it down into our x and y vectors. Because if we remember, the x and y are independent. The only thing that relates to both the x and y vectors is our time. So let's look at this here. We're going to first look at my y side. Okay? Since I know for my y, I know my height, my distance is 500 meters. I know my initial velocity. Okay? My initial velocity here, if we look at this, there's absolutely no velocity at the very beginning in the y. So my initial velocity is going to be equal to 40 meters per, or is equal to 0 meters per second, because we have no initial velocity in the y. We also know now what is going to be my acceleration. My acceleration is equal to negative 9.81 meters per second squared. It's just going to be my gravity. Now, we must also have to try and find time. So that's our variable that we're trying to figure out. Because if we remember, time can relate both in x and y. And in almost to calculate any of them, we need time. Or we could use either of them to calculate time. So let's take a look at this here. Which formula would I use? I would use this formula. That uses all four of these variables. Is we have distance is equal to v initial velocity times time plus 1/2 of our acceleration multiplied by time squared. Now we could just ignore this part because we know my initial velocity is 0. So we get really distance is equal to 1/2 of our acceleration multiplied by the time squared. Now let's rearrange this so we isolate for time. So to get rid of the 1/2, I want to multiply both sides by 2. Then I must divide both sides by a to get rid of my acceleration. Now, it's t squared, so I'm going to square root. That's going to give me t, my time. Okay? So, now let's plug in everything we know. So I'm going to have 2 multiplied by 500. Okay? And that is meters. That's negative. Divided by negative 9.81 meters per second squared. And we want to square root that. So if I calculate this, we have the negatives canceling out. And I'm going to end up getting 1,000 divided by 9.81 meters per second squared. Now that's going to give me a total of 10.1 seconds. Okay? So now let's look at my x. So now that we have my time from using my y, we can now look at my x vectors to find what my whole question wants, the distance before it hits the ground. Okay? So here I'm going to go, we know distance is equal to my velocity multiplied by time. So that's going to be equal to 40 meters per second multiplied by 10.1 4.1 seconds. And what that's going to give me, my seconds will cancel off, 404 meters. So that is how we solve a simple question where we just have a horizontal projector going off a cliff.